Good morning. Welcome to MEDS Gurukul channel. How are you? I hope you and your all family members will be healthy and happy. Today I am starting a new lesson 2, polynomials. Before starting exercise of this lesson, first we discuss about some term like what is polynomial, how many kinds of polynomials, etc. Okay, I am also request to you that please subscribe this channel and share this video in your classmate. Okay, now start. Lesson 2, polynomials. First we discuss some term. Okay, now the first term is constant. What is constant? Okay, a symbol having a fixed numerical value is known as constant. For example, that is 8 minus 6, 5 by 7, pi, etc. Okay, the next variable. Variables, a symbol which may be assigned different numerical value is known as variable. Okay, for example, examples, suppose that C is equal to 2 pi r. Okay, this is a formula. In this formula, this is the formula of circumference of a circle. Here 2 and pi are constant and C and R, here 2 and pi are constants, while c and r are variables, because if r is 1, then c is 2 pi, but if r is 2, then c is 2 to 4 pi. Okay, so the value of r is change, then also the value of c is change. Okay, so this is c and r is also called variables. Okay, next, algebraic expression. Okay, a combination of constant and variable connected by some or all of the operations plus, minus, multiply and divide is known as an algebraic expression. The next, terms. The several parts of an algebraic expression separated by plus or minus operations are called the terms of expression. Okay, for example, in this also example, suppose that we write here 5x plus 4y minus 3z divided 5. Okay, this is also a algebraic expression. For here, suppose that 5x plus 9y plus z. Okay, in this expression contain 3 terms. Okay, in this expression containing three terms. Namely, five x, 9y and z. Okay, the next polynomial. Okay, an algebraic expression in which the variable involved have only non-negative integral is called a polynomial. Polynomial. Okay, example, five x cube minus 4x square plus 6x minus 3 is a polynomial in one variable x. Okay, similarly 9y4 plus 6y3 plus 2 by 5 is a polynomial in one variable y. 3. Suppose 3 plus 2x square minus 6x square y plus 5xy square is a polynomial in two variable x and y. Okay, this is the polynomial of two variable. Now the next, degree of a polynomial. Of first one variable. Okay, one variable, because if we also see the one variable and also in two variable, so the in the degree of a polynomial is different from one variable and two variable. Okay, in first one variable, in one variable the highest power of the variable is called the degree of one variable, degree of the polynomial. Next, two and more variable. Okay, the sum of the power of the variable in each term is taken up, and the highest sum so often is called degree of polynomial. For example, suppose that the polynomial is 7x cube minus 5x square y square plus 3xy plus 6y plus 8. Okay, first we have to take the highest values. For this, the degree is 3, 5x square 2 plus 2 degree is 4, 1 1 2 degree is 2 1, and here degree is 0. Okay, so the degree, highest degree is 4, so degree is 4, sir. Okay, now the next term, polynomials of various degrees. Okay, 1. Linear polynomial. Okay, a polynomial of degree 1, okay, is called linear polynomial. Okay, the general form of linear polynomial is ax plus b. Okay, where a does not equal to 0 and a, b are a real number. Okay, for example, three x plus 5, 5x minus 9, root 2x plus 5, x minus 3 by 8, etc. Now, second, quadrilateral polynomial. Quadratic polynomial. A polynomial of degree 2. Okay, a polynomial of degree 2 is called quadratic polynomial. General form is ax square plus bx plus c, where a does not equal to 0 and a, b, c are real numbers. For example, 5x square plus 9, 2x square plus 5x plus 3, 3x square plus 5x, etc. 3. Cubic polynomial. A polynomial of degree 3 is called cubic polynomial. General form is in variable x, ax cube plus bx square plus cx plus d, where a does not equal to 0 and a, b, c, d are real numbers. Four. Biquadratic polynomial. Biquadratic polynomial. A polynomial of degree 4 is called biquadratic polynomial. General form is ax to the power 4 plus bx to the power 3 plus cx square plus dx plus e, where a does not equal to 0 and a, b, c, d, e are real numbers. For example, x to the power 4 plus 3x to the power 3 plus 4x square plus 3x plus 9. For example, in this case, x to the power 3 2x to the power 3 plus x square plus 9x plus 5, and many other are example. Okay, now the next term, zeros of a polynomial. A real number alpha is called a zero of the polynomial px. Suppose that any polynomial in the px, if p alpha is equal to 0. Okay, now I'm coming to the exercise 2.1. okay, the first question, the graph of y is equal to px are given in figure 2.10. okay, below, for some polynomials px, find the number of 0 of px in each case. Now in this figure, the 0 of px is 0 because the graph is not cut in the axis x dash, no any cut on this axis, so 0 is 0. okay, so answer 1 1. In the given graph, the number of 0 of px is 0. okay, number of zeros of px is 0. okay, because the graph is parallel to x-axis. This graph is parallel to x-axis, does not cut it at any point. okay, in 2, the number of 0 is of px is 1 because the graph intersect x-axis on one point, at only one point. okay, so number of zeros of px is 1. In this question number 3, in the given graph, the number of 0 of px is 3, 1, 2 and 3. okay, because the graph intersect the x-axis at any 3 point. Same, so you write 3, number of zeros of px is 3. Question number 4, number of zeros of px is, in the 4, in the given graph, the number of zeros of px is 2 because the graph intersect the x-axis at 2 points. okay, question number 5, in the given graph, the number of zeros of px is 1, 2, 3, 4 because the graph intersect the x-axis at 4 points. okay, the number of zeros of px is 4. Now the next question, number of zeros of px is In 6th question, 1, 2 and 3. Number of 0 is 3 because the graph intersect or touch the axis at 3 point. Okay. Now I am giving you question for practice. Okay. Now the question for practice, look at the graph in figure 2.9. This is figure 2.9. Okay. Given below, each is the graph of y is equal to px, where px is a polynomial. For each of the graph, find the number of 0 of px. Okay. This is first question, this is second, this is third, this is fourth, this is fifth, and this is sixth. There are 6 questions for your practice. Okay. That's all. Thank you. Good night.